Hey everybody, Baron here. The Riverside kids get me in person today. Heron folks, I'm really looking forward to seeing you again tomorrow, and I hope you had a great break. Here were two highlights of mine. I went to see Virginia play the University of Albany in basketball. I went back and visited family there, and that was really fun. And then my mom loves jigsaw puzzles, so we did this jigsaw puzzle on the right that has all of the national parks on it, which is a pretty educative experience across the board. So we're going to jump in tomorrow a little bit, but I figured since it's a C day, we could kind of use our time wisely today by reviewing some things that we learned last semester and maybe just seeing a little preview of where we're going from here. So I just kind of wanted to draw your attention to that. I'm going to have you take like 4 breaks throughout the course of this time. If you started right when you got in, you should have plenty of time to finish in the 35 minutes. But I would love for you to find somebody else in the seminar space to work with as a partner. And if you look around and you see someone who doesn't look like they have a partner yet, I'd love if you could go up and invite them to join your group. Groups of like 3 or even 4 are fine. I just want you to talk to some people as you work through today. And it'll allow us to kind of review some of the stuff that we did last semester that we'll talk about a little bit more tomorrow. So as you all know, I like to talk about this class in terms of 3 types of problems: number calculations, language problems, and simulation problems. And if you have arrays and substring burned into your brain from the end of the semester, you know we've done a lot of number calculations and language problems lately. But things are going to change a little bit more this semester, and especially this quarter too. Can I simulate more complex problems with Java? You can see on the screen I have a breakdown of all the units of this class. 4th quarter is a little bit of a grab bag, but what we're really doing is taking all of the programming tools that we used last quarter and having them come together to simulate something interesting in real life. And so I'd like to draw your attention to start today to an AP FRQ. We've done a few of these so far in class, but now we're going to dive a lot more into them this quarter, called question number 2 step tracker. And you can reach it by clicking on the tiny URL at the following link, or you can click on the link underneath this YouTube video on Google Classroom and scroll down to page 7, and you will see an FRQ that is of a slightly different format than something that we have seen before. So I would love for you to take about 30 seconds. You can pause the video here and take a look with your friends. What is this asking you to do? What kind of information is it giving you? Go ahead and pause the video and you can get started again once you've got that handled. We're going to solve this problem on January 26th, and you're going to feel pretty good about it when we get to that point. But you notice that there's a lot of information here. There's comments on some sort of behavior that's occurring here. There is some sort of number that's produced. And maybe most interestingly enough is this top left-hand note where it says step tracker TR equals new step tracker. That looks something of the format that we've seen before. This is creating an object named TR of the step tracker class. And what this problem is asking you to do is to create a class. That's what we're going to do this quarter, to create our own classes. Why might we want to do that? Because simulations require blueprints, and blueprints are a fancy word for classes. Remember the control tower program where we told airplanes what to do? We had an airplane class. We made a couple of airplanes. We told them what to do, where to go, how to behave. We're kind of doing the opposite this quarter. Instead of using the airplane blueprint that exists, we are learning how to write the blueprint or the class for an airplane given what its behaviors are. We are writing the blueprint for a class or an airplane given what its behaviors are. We're going to eventually write the program for a step tracker that simulates movement in real life given what its behaviors are, which is the table that we've received right here. So we're going to start small today just by reviewing some of kind of the easiest pieces of this. You will see that this 5 circles are words that we've learned about so far this semester. They are featured at the top of your notes for today. You can do this on paper or on Google Drive if you want to. Why don't you take a couple minutes and pause the video and create a little word web that defines and describes how these things are connected to each other. How these things are connected to each other. When you're done, you can kind of continue on with the video. And I'm going to go ahead and open up the key for these notes, just to kind of remind us that a class is a blueprint, right? We have the airplane class, we have the scanner class, now we have the step tracker class, we have people classes that we've looked at so far, and all classes, if I could get this loaded, have methods that do tasks. They have variables that save specific pieces of information, just like your airplane saved the altitude. And they have constructors, which set the initial values of variables. We also have the word object as a quick reminder, which is like a copy made from the blueprint. It's one of the things of that type. When we had airplanes, we made objects A1, A2, and A3. And they can use the methods that a class has. There's a lot of vocab here that we are going to have to go over. And I have a cheat sheet that's also posted on Google Classroom here in case you forget as we go through how these things are related to each other.